Wonderful, thank you. So yeah, is there actually anyone in the room who has not heard of OCR-D today? You've obviously been asleep for the morning. After you've already heard some talks from various groups involved within OCR-D, I'm now here to give you just a bit of a general overview of the project. What are its targets? What are the areas of activity? How is it structured? So don't expect any in-depth algorithms. You already heard about some of those before. I'm now just going to give you the bigger picture. And of course, since it's a collaborative effort, so here's also the contributors and co-authors from the project. I'm just the one who's speaking. Yes, so how did OCR-D come about? Well, basically, we've seen, and to me, actually, it feels a bit like Groundhog Day to standing here today and speaking about an OCR framework. I think I did basically the same thing 10 years ago for the Impact project, which is listed here. There were also other projects. MetaE was one that delivered, for example, the Alto standard. There was a project, EMOB in the US, several others that I didn't mention here. But somehow there was still, despite all these projects, a lack of, well, first of all, completely fully open software and also comprehensive tool suite, so to say, for OCR, focusing specifically on printed documents. And by comprehensive, I mean, you probably all know that there's various steps in this workflow, starting from image optimization, layout analysis, and so forth, as we will see in a few minutes. What also fortunately has happened now within these last 10 years, that it's actually not Groundhog Day again, is that we have seen this rise of machine and deep learning, and that has really delivered tremendous improvements to what is possible now with OCR, even for complex historical documents. So it was time to leverage these technologies in a comprehensive way. And of course, we see also with the advent of digital humanities that the demand for delivering also high quality OCR data for analysis and study by scholars is rapidly growing. So this all led to the setting up of the OCR-D project in 2015 with funding from the German Research Foundation. And it's sort of like a multi-phase approach. So there was an initial phase which lasted about 2 years where basically there was a survey of the state of the art, and we tried to identify where there were specific gaps in available technology. From that, we delivered a call for projects, which then led to a number of research groups from universities, from research centers, applying to tackle these challenges. We're going to hear more about that in few minutes as well. So yeah, the main goals, as you can see, pretty standard. So we want to develop software targeting these various processing steps, but with a focus specifically on printed material, historical printed material. Of course, you already heard the talk this morning by my colleague Konstantin Bayerer, standardize on metadata and particular ground truth, which of course also with machine learning and trainable algorithms has become of much more importance. I totally second what Ashok, where is he, said before, that probably we're going to have new magic algorithms in a few years, but what is really important then to have also the right data to leverage these benefits. So yeah, as I just said, OCR-D is structured in such a way that there is basically a coordination group or coordination project, which is composed of 4 partners. There was a change of partner in between in 2016. And as I've just mentioned, from this coordination group, we did this gap analysis and issued this call for projects that then led to the funding of 8 separate module projects that then target the implementation of the solutions for these problems. And we're currently in this second phase, so to say, which runs still until early 2020, where we will then have the final results of these sub-projects. Well, what is of course an important task to keep all these different developments together is to have very precise and well-documented specifications how these software projects should deliver their algorithms and solutions in order to enable a comprehensive framework that can well integrate these different algorithms for processing. So we focus on the command line as the least possible barrier for providing compatibility across platforms and in an easy way so that the developers can mostly focus on developing the algorithms rather than struggle with any integration effort. We standardize on METS as the main format for data processing and exchange within OCR-D. The reason being that OCR-D is within Germany, METS within Germany is a requirement. If you receive funding from the German Research Foundation for Digitization, you have to deliver a METS according to a specification that they provide. And so we thought, okay, if there is already this level of standardization, let's plug into that. So the idea within OCR-D is to get a METS document, which typically has some descriptive metadata about the publication, and then it holds references to, for example, the image files. And so what we do in OCR-D, we take these METS files, we parse them for the information. Some of the information we use for the parameterization of the processing. And then we fetch the images from the locations that are referenced in the METS container and submit them iteratively to the various processing modules. For the full text OCR, we decided to use the PageXML standard, which is developed here by the group from University of Salford, simply because it's in the scientific pattern recognition domain. It's the prevalent standard that is also used for various competitions, and it's basically the richest, the format that can hold the richest amount of information. However, we already foresee cross-transformation scenarios to, for example, Alto or HOCR, which are more in use than in the production workflows in the library domain. We also require that the software that is delivered by these module projects provides us with an OCR-D tool JSON, which basically describes the parameters of the tool and in a standardized way. And the modules also need to provide a Docker file so that it's easy to install and deploy these technologies via Docker. And for long-term preservation of OCR data, we use this OCR-D zip format in combination with Baggett, as we've also heard about in the talk before. And all of these specifications and conventions are openly developed from the start on GitHub. So we have our GitHub repository, which is linked here. It's also just GitHub OCR-D if you want to look it up. And basically all the development and refinement of the specifications happens out there in the open. So please feel free to have a look and get involved. Of course, for these specifications, we also provide a reference implementation from the coordination project, which is done in Python. And also that is, of course, openly available. So we require the Apache license for all the software that we develop so that it's really reusable also in commercial environments. And this basically provides some helper functionalities for frequent tasks like fetching data from the METS file, conversions, etc. It has validators that can check whether your data or the tool actually fulfills these specifications. And it also holds an OCR-D scaffold, which you can basically use to create your own tool according to these specifications, but you don't have to. This whole core software is, like I said, is developed in Python, Python free. If you're using Python, you can easily install it via pip, and we really take a lot of care into the development of this software about continuous integration, code coverage, and so forth. So yeah, also here, feel free to have a look and try it out. This is also something that reminds me a bit of the past. So also in Impact, we designed a workflow. Scientific workflows have the benefit of documenting well the data flow through the various processing steps. And what is quite important also now, especially with digital humanists analyzing the resulting full text, is to capture the provenance about how these data were derived. So what tools were used, what combination and sequence, what parameters, what models were used to create that text. You want to know that if you study the text, and you want to understand the quality and the constraints and how they've been derived. Excuse me. This I think I don't have to go into any more at length because we already heard about that. So we, of course, provide also comprehensive transcription guidelines for ground truth in various levels. Level 3 that has already been mentioned is really very challenging. So this requires also, for example, the mapping of ligatures to their specific Unicode code points and so forth. The transcription guidelines itself is the only thing coming out of OCR-D, I think, at the moment, which is only available in German. Everything else is in English. But we have that on the horizon to also do an English translation of that. Yes, the rest I think has already been mentioned. So there's various sets of ground truth already available. Also that data you can just easily download from those URLs, and more data is currently also in production. Okay, so did I miss a slide here? No. So okay, now let's dive into these modules. So I'm just gonna, as I said, quickly summarize what are those different modules, what are they working on. So in total we have 8. The first one is also the first step in the processing workflow, image optimization, and you have here the, I think, quite familiar common pre-processing methods, desqueuing, so skew correction. Dewarping, which is a bit more challenging, is where you have a non-linear warping on the page, for example, caused by humidity. Here we're using, or the colleagues from the, sorry, I should mention this is sub-project is being worked on by the German Research Center for Artificial Intelligence in Kaiserslautern, the group of Andreas Dengel. And yeah, so they have some preliminary technologies already for these image optimization. They have a deep learning model for dewarping. And then you have, of course, the classic things like cropping and binarization, where especially cropping is something interesting. I think in OCR-D we've had the discussion, do we want to remove only, say, borders that are a result from scanning artifacts, or do we really want to crop to the print space? Actually, when you look up the definition of the print space, according to the print history, that may, for example, exclude marginalia, which is what we don't want. So actually, it's probably something more like border removal that we're interested in. And whenever there is source code already available, it is linked here. And this is the case for every module except this one, where we don't have any code contributions yet from the partner. So you see this is the second step, the layout analysis, which is also operated by the same institute here in Kaiserslautern. And also here we see the common tasks, starting with page segmentation, then going to line segmentation. We don't have to do word and character segmentation anymore, as we know these new segmentation-free methods based on neural networks don't require that anymore. There is an approach to do region classification using a convolutional neural network, and some work is also foreseen on the global document analysis, for example, to reconstruct a table of contents or identify chapters and other structural elements on the document level. The third module, and this is, as you can see, a bit of an artifact of the funding of issuing a call where projects can apply. You may also end up with having 2 modules that work in a similar area. So we have also another module that works on layout analysis and region classification. Actually, the colleague who has been developing that has just presented the automated tagging for the historical data, Christian Reul. So there was already a technology called LaRex that is also open source and linked here, and this will be extended with a CNN-based pixel classifier, and they also foresee to integrate some rule-based and heuristic methods to further improve the layout analysis quality. And the main focus, I think, is here, since LaRex is a tool that was based on user input to do the segmentation, is to try to move this to the highest possible degree of automation. As I think, have I mentioned that within OCR-D, the target is all printed German documents from 1600 to 1850. So we definitely need something which works without much user interaction. And also here a prototype is already available on GitHub. We also have in the area of post-correction 2 modules. Also one that we've already heard about, the Pocoto, but there's also another one here operated by the Computational Linguistics group in the University of Leipzig. And here the approach is to combine finite state transducers with a recurrent neural network for post-correction. And they are also currently developing some tools to create historical and document-specific language models to support this automata-based post-correction. So currently there's 2 tools, one which does the FST post-correction, one which uses the neural network. And I think one of the next things will be a cross-evaluation or possible integration of these. Well, we have a module that is for OCR, that is Tesseract, and you may wonder how come, because Tesseract is a tool that is developed by originally Ray Smith and a wide community. Well, we are very lucky that at the University Library in Mannheim, one of the guys in the digital library there, or the head of the digital library, Stefan Weil, he has been very actively involved in the main Tesseract code, and he's become a maintainer of Tesseract. So even at times like now in the past year when Ray Smith is busy with other things, he can merge pull requests, he can improve the main source code for Tesseract, and so all the developments that we do now also through this OCR-D project go into the main Tesseract branch. We don't do any fork or separate version of it. So everyone who's using Tesseract as an OCR engine will also directly benefit from the improvements that we do within the OCR-D project. And that includes, for example, some things as maybe some of you already seen. As of recently, Tesseract provides native output of Alto, not only HOCR or plain text, but you can now also natively output Alto. They will do some improvements to the code quality, by, for example, through fuzzing and various other technologies. And of course, again, given the scale of OCR-D that I've just mentioned, there is, of course, an emphasis also on speeding up the processing with Tesseract, since you may have seen, if you've used Tesseract before, version 3 was very fast. Version 4 with the neural network is not so fast anymore. And there is still also some room of improvement in that area. However, since OCR-D, the OCR-D framework is Python-based, we also provide a Python wrapper here, OCR-D TesseraOCR, which then allows you to call that through Python and the OCR-D framework. Yeah, I've just mentioned, following here the order of the modules as they are sequenced in the project, there is also a second post-correction system that is being actively developed in the, under the frame of OCR-D, and this is using the technology that we've already heard about also before from Florian Fink. So there is the Pocoto system that has been developed over many years in the OCR error profiler, OCR profiler at the CISC group in the University of Munich. And also here, the system is being tuned to adhere to the OCR-D specifications and interfaces, and also here to move from mainly a GUI tool to an automated processing tool like we've learned about before. It uses multiple OCR engines. It aligns these outputs. It uses the OCR error profiler then, which is a technique that Florian already explained before, and to do the automatic post-correction, and then you still have the possibility to optionally do some interactive post-correction. And this is a very interesting combination. Here we have actually two activities within one module project. So this is a collaboration between universities of Mainz, Erlangen, and Leipzig. And there is a group of book historians that collaborate with a machine learning expert in Erlangen University to develop a system for script identification. And so I don't think you can really read the screenshot here, but we just presented this at a German DATeCH conference, and there are some very promising results about being able to detect also within, for example, the family of broken letters, specific font families, which of course we want to use in a pre-processing step to then determine the best suitable model for the actual recognition of these texts. However, there's also a second part to this project, which is concerned with the development of an infrastructure for training OCR models. So where you can provide training data, upload training data, and then with the push of a button, basically, is the idea. You can, from one set of training data, create a model for a variety of engines. So currently, I think Octopus and its various forks, so Kraken and Calamari, are already supported. The developer here is currently working on integrating also Tesseract. So this, we believe, can be quite helpful and interesting to have a central repository where you have this data that has been used to train the models, as well as the models itself, so that you can just grab one from there. And that really simplifies the process of training such models, which, especially with Tesseract, can be very cumbersome. And yeah, last but not least, suppose we went through all these processing steps, we have derived a high-quality OCR result. There is, of course, a need to preserve that for the long term. And this is where the Göttingen State University and the GWDG, I don't think what's the English term, but the IT development group for humanities and whatever, what have you, something in Göttingen is working on. And so here the idea is it's actually a bit of a combination of research data management and long-term preservation, because the requirement from the users is to have a repository where you can easily, permanently, persistently access OCR results. Also, say, different versions. You were working, say, with one version, then a new, better OCR result is derived, but maybe your study or analysis is based on the first version, so you want to be able to address various versions, and you also want to be able to cite a version. And this is something where we're also looking into how granular that could be. So that can be the page level, or it can even be on the level of some segments like regions or lines. And of course, you also want to be able then within this archive to search based on the descriptive metadata or what we've seen before, the semantic labeling of these full texts to derive exactly the data that you're interested in. And I think, yeah, also this is a bit of a repetition. So if you haven't been quick enough to take a screenshot before, now is your second chance. Here, basically, you can find all the OCR-D products and channels. Like Konstantin already mentioned, we have a chat on GitHub where we welcome everyone. Conversations are by default in English, so don't hesitate about the D in OCR-D. Docker files are provided via Docker Hub, and basically all the other stuff is mainly on GitHub and is open. So please have a look and get involved. Thank you very much.
Thanks very much, Clemens. We've seen various different presentations for OCR-D, but it was brilliant to see that overview. Right, who's got questions for Clemens, please? That's very sorry.
You've already had enough of OCR-D. Anyway, if you don't have any questions now, I will be sticking around also until tomorrow afternoon. So feel free to grab me at any time if something comes up, or Christian.
Yeah, thanks, Clemens. Maybe just one, because there are so many things. Are you planning any workshops or something to maybe invite people to learn about all these things a bit more in detail?
It's a very good point, yes. So from the project, we only have a budget for doing internal developers workshops. We are, of course, through the funding situation also here a little bit constrained. So typically we can invite people to these workshops that are developing in the area of OCR, but we cannot provide any funding from the project for reimbursement of travel or accommodation. But there's currently, for any Germans in the room, I'm sorry, there's a workshop being planned at University of Halle for June. Which is also open for everyone to join that is working in the area of OCR. But this, I think, was a very important opportunity here at DATeCH to internationalize the project and really make everyone aware of the fact that it's not just a national effort. It has national funding, but of course the code, the solutions, everything adapts well to other languages equally. And I think it's a very good idea to bring this more to the international domain and look into opportunities for funding or other ways to do a collaborative workshop on an international scale. And I think that would be very desirable.
And maybe just interconnecting with that, the sort of interconnecting with Daria, Clarion, other networks like that, I'm sure piggybacking, for want of a better term, on other initiatives, that would be a great opportunity to be able to do this.
Absolutely, yeah.
Fantastic.
Hi, I was interested in your de-warping with machine learning, and you showed an example from a journal or a monograph, I think. Are you also trying with historic newspapers?
So I have a bit of a newspaper hat since I've been involved in some newspaper projects. The thing is, so OCR-D from the funder's perspective was focusing on the what is called in Germany the VD-Projekte, the VD projects, which is an inventory of the printed documents excluding newspapers. But of course, we have an intrinsic interest in newspapers there as well. From the call for this particular sub-project that is working on de-warping, they are not required to do that. And we've only seen also a very early prototype of that de-warping, so we didn't really try it out on newspapers yet. But we do see newspapers as in scope, for example, especially in the area of layout analysis, where we see that many of these challenges are probably more in the newspaper domain than in the historical documents domain. So whenever there is, say, the possibility to do with some quick effort and small labor, something that will benefit also newspapers, we will try to catch that, but we don't have any specific target for newspapers there.
Thank you. Well, I think we've got several of them. We've got to get to, we're a little bit behind time, so I think if we can thank Clemens again.